Hey, basic electricity. I gotta run you through some basic electricity stuff. Now realize there's several other classes. There's, electrical one and electrical two that go into great depth in this. So my job today is just to kind of give you just a, you know, very cursory understanding of this. I'm sure you guys have, you know what electricity is. I mean, you've been using it. You turn on a light switch in your room, you turn on the turn signal in your car, the light bulbs light up. It's basically the same function. So, and honestly, electrical is one of my specialties. I am the electrical guy. So take more classes. Okay, so here, let's just get through some of the simple intro to electricity, basic electricity stuff. We have electricity in cars. As a matter of fact, you couldn't think of virtually anything. I mean, go ahead and try. Give me, give me something that's not electrical in a car. I mean, there really isn't anything. I mean, tires. We have tire pressure monitoring system. Windows. We have power windows. We have the rear view mirror on the car. Those are electric or they're chromatic and they change color. They auto dim. We have we have seats. We have power seats. We also have sensors inside the seat that monitor your temperature. So if you're hot or cold, the automatic climate control kicks in and either gives you heat or cool based on the temperature of your back or your butt. I mean, honestly, try to think of something that's not electrical. I mean, we even have electrochromatic paint on cars now. You want to see something cool? Google that. So, I mean, virtually everything we come in contact with is electrically driven at this point. I mean, it's amazing what we've managed to electrify in modern vehicles. So honestly, with a basic understanding, if you have a good solid foundation of understanding how electricity works and how circuits work, it really gets a lot simpler. I mean, I look at a wiring schematic. It's like a road map that tells me how something works. You know, honestly, it, 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 it makes it real easy for me. Anyways, moving along. So things we're going to cover voltage and current and resistance, and then, some testing stuff, digital voltometer. All right, voltage. It's the electrical pressure measured in volts. Uh, Typical vehicle voltage that we deal with in most stuff is, 12.6 volts would be standard voltage of a car battery fully charged. And then running voltage is like 13.8 to about 14.2, 14.2 volts. So, it's kind of much lower voltage than, let's say, what's in, the outlet in your room, which is 120 volts. That's a lot more. That's also AC, and we're talking DC in the car. Do we have higher voltages? Yes, we do. Some ignition system voltages run at, 60,000 volts. And then we have some computer controlled stuff that runs at like 5 volts. So there is a big range of voltage that we deal with. And then we look at hybrids. Some of those things are, 300 volts DC inside of a car. Get it? The sources of voltage that we use, the sources that we have is the battery and also the alternator. So typical fully charged battery is about 12.6 volts. But when the car is running, the voltage rises up to about 13.8 to 14.2, somewhere in there. Current. Current is the flow of electrons. That's the movement of the electrons through the circuit. More current is more work. okay? Higher the current, the higher the work that's done. I mean, we look at like the headlight. That's pretty bright. Or we look at the little tiny bulb that like lights up the gas gauge. Which one does more work? Well, the brighter one. Or we have, the power window motor. That's a lot less work than, let's say, the starter motor. Get it? Higher current, more work. The flow of electrons. It's measured in amperes. And think of it as the water flowing through a water pipe. This is the work of the circuit. What are we asking it to do? All right. Resistance. This is the opposition of current flow. Now, here, it's measured in ohms. All electrical loads have some resistance in them. The higher the resistance, the lower the amperage. Little tiny light in the fuel gauge, high resistance, low amperage, low work. Starter motor, very low resistance, high amounts of amperage, lots of work. Remember that. Take nothing else out of this. That's the part you got to remember. Higher resistance, lower amperage, lower resistance, higher amperage. Got it? So here's a simple automotive circuit, and it has all the parts that we look at. We have the battery, or the source of the power, alternator as well. We have the fuse, which is the protection in the circuit. We have some way to turn the circuit on and off, a switch, and then we have a load. In this case, it's a light bulb. It does something useful for us. The load rolls up and down the window. The load is what, turns on the little light in the ashtray. And then we have to have a complete path. Now, most ground circuits in cars use the body as the return or ground path. Get it? The metal car body is used as one of the wires. So basically what we're able to do is, instead of running a power and a ground, we just run a power out. Get it? Saves some wiring, saves weight. So all simple circuits have these things. We have a power source, control device, some way to turn it on and off, wires, and a load. Circuit protection. We have two types. This is, a fuse or circuit breaker. And I'm going to be showing you those when we go outside. These are intended to protect the wire, not the load. So here, the one thing I hear people say is, it blew a fuse, and what that means is it just needs another fuse. Fuses don't blow for no reason. Never, ever seen it happen. If the fuse blows, it's because it's drawn too much amperage. Okay? The fuses are there so you don't die in a fiery death. All right. We have a couple different types. We have the old glass style, and that's really old. That's older than most of you. And then, we have the new plastic ones, the ATOs, the maxi fuses, and these come in different current ratings, and they're different colors. And never, ever install a larger fuse. If it comes with a 10 amp fuse, that's the only fuse you put back in. Significant damage can be done if you don't follow that rule. All right. Old style glass fuses, these aren't used anymore, although you may see them. There's metal on the end, there's glass in the middle, and you can actually see the fuse element that's inside. And they're rated at different amperages, 4 amps, 6 amps, 7.5, 14, 20. This is the new style, or ATO or mini ATOs are common. You can see the fused element. This is a broken fuse element. This is a blown fuse. It has taps on the top in order to check the fuse for power. So one side's power in and one side should be power out. There should be power on either side. I'm going to show you how to do this. A multimeter. This is really what professional technicians use. Here's mine. This is a Fluke 88. This is a very expensive multimeter. Do you need something this expensive? Nope. I would suggest spending, I don't know, $50 on one. Buy a decent one. But I wouldn't suggest buying a really high quality one. I mean, this thing's 500-600 bucks, man. No reason to need it. Show you how to use it. I got it on the lab. We can also use what's called a 12-volt test light. I'll show you the picture next, or a DVOM. Now, here's my test light. I use this quite often. And all it is just a light bulb on a stick. It's got a little clippy thing on it. I'm going to show you how to use one of these things. It's great for testing power. You know, basic checks. I'm just going to grab a test light. I want to see if a fuse is good. I want to see if something's got power. I'll just use a test light. I have different test lights that do different things. Okay, so summary. Voltage, resistance, and amperage, current are related together. Low resistance, high amperage, high resistance, low amperage. Remember that part. Okay? And then, how to use a meter. And I'm going to show you how to do that and do some fast checks. And we're going to do some stuff with a meter out in the lab. Okay? Some different types of test equipment. That's about it. Thanks for showing up.